Good morning, ma'am. My name is Kaushik, and today I am here to present our project PyPhotoEditor, a mini Photoshop in Python. Our group members are myself, Kaushik Ram, Mahin, and Ritvik. Our problem statement. Nowadays, many people want to edit images for simple purposes like editing, adding text, adjusting brightness, or applying small effects. But most professional tools like Adobe Photoshop are very costly, difficult to understand, and require a powerful computer. Many users don't need advanced features, they only need the basics. So we'll feel that there is a need for a lightweight and user-friendly alternative. This is what inspired us to develop PyPhotoEditor. What is PyPhotoEditor? PyPhotoEditor is a very simple desktop application made completely using Python. It allows users to open, view, edit, and save images easily. Our main goal was to make editing faster and more accessible, even for the beginners. Also, through this project, we wanted to learn how Python can be used beyond text programs for real-life visual applications. What are the key features? PyPhotoEditor provides multiple useful options like opening and displaying images, grayscale conversion, blur effect, brightness adjustment, adding text watermarks, pencil sketch effect, and finally saving the edited images. So overall, it includes all the basic functions needed for a simple editing. Tools and technologies. We have used Python 3 as the main programming language. For the graphical user interface, we used Kinter. For editing functions like grayscale and blur, we used Pillow library. For the sketch effect, we used OpenCV, which is a computer vision library. And at the end, we packaged the project into a standalone.exe file using PyInstaller so that anyone can run the application without installing Python. How the images are handled internally. To make the app efficient, we always keep two copies of the image. High quality master image where all the edits are applied, a smaller resized preview that is shown on the screen. This reduces loading time and keeps the final saved image high quality. Basic filters. Filters like grayscale and rotate are very easy with Pillow. When the user clicks a button, Pillow modifies the master image and updates the preview instantly. This makes the editing smooth and fast. Enhancement filters. For blur effect, we used Gaussian blur from Pillow's image filter module. For brightness adjustment, we used Image Enhance. These features help users improve the look of the photo creatively. Adding text feature. In this feature, users can add any text on the image like a watermark or a caption. We used Pillow's image draw tool to draw the text. Also, if the Arial font is missing, our program automatically uses a default font to avoid errors. So the program remains stable. Sketch effect. This is one of the most interesting features in our project. We used OpenCV to convert the image into a pencil sketch. The algorithm does multiple steps such as making the image grayscale, inverting it, blurring it, and finally dividing both images to get a hand-drawn sketch style output. We used two libraries together, Pillow and OpenCV. Do not use the same image format, so they directly share the image. To solve this, we used a very simple but effective method. First, OpenCV saves the sketch output temporarily. Then Pillow loads the file back as a new master image. So both libraries work together smoothly, improving the user experience. We also focused on making the application safe to use. For example, if the user tries to apply a filter without loading an image, a warning pop-ups appears instead of crashing. This makes the software more user-friendly for everyone. In conclusion, PyPhotoEditor is a simple and lightweight image editing tool created using Python with the help of Kinter, Pillow, and OpenCV. Through this project, we learned GUI programming, image processing, and also how to build a complete working software product. Thank you.
Good morning, ma'am. I am Mohammed Mahin from the cybersecurity class and from the group 14 of the AI project. Our project is the PyPhotoEditor in which we can upload the photos and edit the photos as we wish. So here are the options of our in our interface: open, undo, redo, grayscale, blur, rotate, brightness, contrast, add text, sketch, and the save option. Open is for selecting the image you want to edit. For example, I'm selecting this image. And if I want to apply the grayscale effect, I click on the grayscale button and the grayscale effect gets applied. And if I want the grayscale effect to be of higher intensity, then I keep on clicking the grayscale effect button. And if I don't want the grayscale effect, I can just click on the undo. If I want the blur option, I can blur effect, I can click on the blur button. If I don't want the blur effect, I can click on undo. I can rotate the image as I wish. I can increase the brightness or decrease the brightness. Let me decrease the brightness in this. I can increase the contrast or decrease the contrast. I can add a text as the character here is Shinshan. Let me add Shinshan. And Shinshan, the text is the text effect gets applied. And if I don't want any of these and I just want the sketch effect, I can just click on the sketch effect option and the sketch effect gets applied. And if I want to save my image, I can save my image on my computer with the name of Shinshan. So this is our user interface of our project. So I'll be explaining the code now. At the top, we import the required libraries. tkinter is for GUI components. File dialog lets us open and save files. And message box is for showing warnings or info messages. And simple dialog lets the user enter the text. Whereas pil.image, image.tk, and so on are for image processing tasks. And then OpenCV is for the sketch effect. And next, class initialization. We define the photo editor class and pass the root tkinter window. In the init method, we configure the window title size, background color, and so and so. This is the background color here. And then we initialize the variable self.image to store the current image. We also create self.undo stack and self.redo stack to further undo and redo operations. And next, the header and the canvas. We create a header using the tk.label with the text py photo editor. Below that, self.canvas is a tkinter label where we display the image. The canvas has a white background with a grooved border for visibility. And then next we create the buttons. We define the buttons inside btn underscore frame. It holds all the buttons. The buttons like open, undo, redo, grayscale, blur, and so on. And then we move on to the sliders for brightness and contrast. The sliders which I've kept in my interface. we create we create the sliders using this concept. We create using the we store the sliders in self.slider underscore frame, but initially hide it using self.slider underscore frame dot pack dot forget, which is here. And then next, the undo and redo functions. We define the push underscore undo to save the current image, and undo pops the last state from the self.undo stack and pushes the current image onto the self.redo stack. Here is the undo and Here is the undo and redo functions. And then next we move on to the open image, opening and displaying of the image. The open underscore image is a function which uses file dialog dot ask open file name to select an image. We store the path in a self.path and load the image with image.open. This show.image resizes the image. And then we go on to the filters, which is the grayscale and the blur filter. Grayscale converts the image to black and white using the self.convert, the function here, which is L, this particular line. It convert RGB stands for red, green, blue. And then the next function is this is the blur function. This is the code for the blur button. And then next is for the rotate option. If there is no image loaded, I have added a message which tells warning, no image loaded. And then the brightness and contrast application. Clicking the brightness or contrast shows the slider and sets self.slider underscore mode. We apply underscore slider dot value reads the slider using value using the self.slider dot get brackets. And then the next one, adding the text. Add underscore text opens a dialog using simple dialog dot ask string. The user can type any custom text they want. And then the sketch effect. The sketch effect function uses OpenCV. OpenCV is mainly used for, not mainly, but it is in this code, it is used for the sketch effect. First, we read the image with cv2.im read brackets self.path and convert it to grayscale. And then we invert it, blur it, and using the Gaussian blur option, and then saving the image. The save underscore image function opens a file dialog using file dialog dot ask aveas. This one, ask save as file name. Save image option. In this is the code for saving the image. The save underscore image function opens a file dialog using file dialog dot ask save as file name and saves the current image. You can save the image in any format, which is .png or .jpg. And then when the image is saved, a dialog box appears, and it tells you that the image has been saved. And then the last part, running the app. This part initializes the tkinter with this part, and runs the app using this part. So this last function is mainly for running the app. Thank you, ma'am.